Hey y'all, today is March 23rd and we are doing a little mini lesson on compound probability, which goes kind of with what we did in class today. So grab a piece of paper and a pencil and a calculator if you want it. So let's get started. Okay, so we're looking at this first one right here. It says, what is the probability of flipping tails and then rolling a 5? So we've got a coin that we're flipping, so it's either going to be heads or tails. So I'm going to write this as the probability of tails. I know the probability of tails is either going to be, I'm either going to land on tails or on heads, so it's 1/2. Now, the probability of rolling a 5 on my dice. Well, that's a standard 6-sided dice, and I know that 5 will show up one time on that dice. So it's going to be 1 out of 6 total outcomes. So now to find the compound probability, the probability of both events happening, I'm going to take this fraction here and multiply it with this fraction here. So I'm going to write this as 1/2 times 1/6. And I always want to check to see if anything reduces. And I always do that diagonally. So 1 and 2, I can't reduce those. 1 and 6, I also can't reduce those. So nothing here reduces. So I'm just going to multiply across. So I'm going to start with my numerators. 1 times 1 is 1. And now I move to my denominators. 2 times 6 is 12. So the probability of both events happening is 1/12. Okay, let's move on to number 2. What is the probability of rolling a 4 on the first die and a 6 on the second die? Okay. So I'm going to write my probabilities separately here. So rolling a 4 on the first dice, so probability of getting a 4. Well, that picture shows us a standard 6-sided dice. So I know that 4 will show up one time and there are 6 total outcomes. Okay, now for my second event, my second probability, it says rolling a 6 on the second dice. So probability of rolling a 6. Well, that's again another standard 6-sided dice. How many times does 6 show up? Just one time. So I get 1 out of 6. So now to find my compound probability of both events happening, I'm going to multiply this fraction with this fraction. So we have 1/6 times 1/6. We always want to check to see if anything reduces, and we look diagonally. So 1 and 6, can I reduce those? Nope. What about this way? 1 and 6, can I reduce those? Again, that's a no. So I can't reduce anything, so now we just multiply across. Let's start with our numerators on the top. 1 times 1 is 1. And then on the bottom, my denominators, 6 times 6 is 36. So my probability for both events happening is 1/36. Okay, number 3. A coin is tossed, then a letter from the word incredible is chosen at random. What is the probability of getting heads and then a vowel? Okay, so the first event happening is tossing the coin, right? So the probability of getting heads. The probability of heads. Well, when I flip my coin, I'm either going to get heads or tails. So probability of heads is 1 out of 2. There are 2 total options, there are 2 total outcomes, and heads is one of those outcomes. Now for my second event, the second event is getting a vowel out of that word incredible. So the probability of choosing a vowel. Now, I just want to remind everyone what a vowel is. Vowels, we are going to consider them as A, E, I, O, and U. Just those 5 letters. So first, I need to know how many letters are in that word incredible. Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 letters total in that word. So that's my denominator. 10 goes on the bottom. Now my number of vowels are the favorable outcomes, so that's going to go on top. So my vowels are I, E, I, and E. So how many vowels are there? Well, there are 4 vowels that I have circled. So we have 4/10. Now that does reduce. I know 2 goes into both of those numbers. 4 divided by 2 is 2, and 10 divided by 2 is 5. So now that I've got my 2 probabilities, I'm going to multiply them together to figure out my compound probability. So I'm going to multiply 1/2 times 2/5. So we'll set that up like this, 1/2 times 2/5. And we always want to see if anything reduces, and we look diagonally. So 2 and 2. Well, 2 goes into both of those numbers, and they can cancel out to 1. So that becomes a 1, and that becomes a 1. Now let's look the other way. 1 and 5. Can't reduce those, so now I'm just ready to multiply, and I multiply across. Well, on the top, I've got 1 times 1, which is simply 1. And on the bottom, I've got 1 times 5, which is 5. So my probability is 1/5. Okay, now let's move on to the fourth question. If a coin is tossed twice, what is the probability of getting heads both times? Okay, so the first event is we're tossing a coin, and we're wondering what is the probability of getting heads? Well, we've talked a lot about this already in this video. I'm either going to get heads or tails, so there are 2 total outcomes, and heads is one of those. Now, that's our first event. Our second event is tossing a coin and getting heads, right? Because it said getting heads both times, okay? So my probability of getting heads for the second toss is the exact same. So now I'm just going to take these 2 fractions and multiply them together. So we have 1/2 times 1/2. Well, does anything reduce? Nope, nothing reduces, so I'm just going to multiply across, starting with my top numbers. 1 times 1 is 1, and now moving on to my denominators on the bottom, 2 times 2 is 4. So the probability of both events happening is 1/4. Okay, let's move on to the next one. Each spinner is spun once. What is the probability of spinning a number that is at least 3, then a square? Okay, so probability of at least 3. So at least actually means greater than or equal to. So this is our first probability. So we're looking at our first spinner right here. So at least 3 means 3 or more. So I'm looking at 3, 4, 5, 6, 7, 8, 9, and 10. Well, how many sections is that? That's 8 of my 10 total sections. So 8 over 10. Does that reduce? Yes. 2 goes into both of those. 8 divided by 2 is 4, and 10 divided by 2 is 5. So 4/5 is the probability of my first event, getting at least 3. Now my second event is getting a square. So probability of a square. Okay, so I'm looking at my second spinner now. I'm looking at this one here with the shapes on it. So I need to know how many total sections are on that spinner. I know it's not as many as the first spinner, so I'm just going to count them. There's 1, 2, 3, 4, 5, 6. So there are 6 sections, and how many of them have a square in them? Well, number 6 has a square, and number 2 has a square. So those are the only 2. So 2 out of 6. So 2 favorable outcomes out of 6 total outcomes. Does that fraction reduce? Yeah, 2 goes into both of those numbers. 2 divided by 2 is 1, and 6 divided by 2 is 3. So now that I've got the probabilities of each event, I'm going to multiply them together. So we're going to have 4/5 times 1/3. So let's look to see if anything reduces. 1 and 5 doesn't reduce. 4 and 3 also doesn't reduce. So I'm just going to multiply across now. 4 times 1 is 4, and 5 times 3 is 15. So the probability of both events happening is 4/15. Okay, we've got 2 more. A bag contains 2 Snickers bars, 8 Twix bars, and 5 Crunch bars. A candy bar is chosen, replaced, then another bar is chosen. What is the probability of choosing a Twix bar and then a Crunch bar? Well, first, I need to know how many candy bars I have altogether. So I'm going to add up these numbers. So 2 Snickers plus 8 Twix, that's 10, plus 5 Crunch bars. That's 15 candy bars total. So 15 candy bars. okay? So now the first probability is probability of choosing a Twix bar. So the probability of, I'm just going to call it T for Twix, okay? Well, how many are Twix bars? 8. 8 of the 15, right? Can I reduce that? No, 2 doesn't go into both, 3 doesn't go into both, so I don't think I can reduce that. Now my second probability, the second event is choosing a Crunch bar, so I'm going to call it probability of C. So how many Crunch bars do I have? 5. So there are 5 Crunch bars out of 15 total candy bars. Does that fraction reduce? Yes, 5 goes into both of those numbers. 5 divided by 5 is 1, and 15 divided by 5 is 3. So now that I've got my two probabilities, I'm going to multiply my two fractions together. So I'm multiplying 8/15 times 1/3. So 8/15 times 1/3. Does anything reduce? Remember, we look diagonally. So 1 and 15 doesn't reduce. 8 and 3 also doesn't reduce. So I'm just going to multiply across, starting with my numerators on top. 8 times 1 is 8, and 15 times 3 is 45. So 8/45 is the probability of both events happening. Okay, last one, and we've got a part A and a part B. So in part A, it says a box contains, let's just read the problem first. It says a box contains 8 apples, 10 fruit punch, 10 grape, and 12 berry juice boxes. A juice box is chosen at random or placed, and then another juice box is chosen at random. Find each probability as a fraction in simplest form. Okay, so let's look at A first. So the probability of berry and then not fruit punch. Well, let's focus on just this probability of berry first, okay? So first I need to know how many juice boxes there are total. So I'm going to add up my numbers. 8 plus 10 is 18, plus another 10 is 28, and plus another 12 makes 40. So I have 40 total juice boxes. Okay, so the probability of choosing berry. Well, there are 12 berry juice boxes. So 12 out of 40. Does that fraction reduce? It does. I know that 4 goes into each of those numbers. 12 divided by 4 is 3, and 40 divided by 4 is 10. So 3/10. So that's my probability of choosing a berry juice box. Now, it says then not fruit punch. So anything but fruit punch. And notice there are 10 fruit punches, right? So 40 juice boxes minus 10 fruit punch leaves me with 30 that are not fruit punch. So we're going to have 30 out of 40 that are not fruit punch. Does that fraction reduce? Yeah, I could just take off those zeros and I get 3/4. So now what do I do? Well, now I multiply my two probabilities together. So 3/10 times 3/4. So 3/10 times 3/4. Does anything reduce? Look diagonally. So 10 and 3 don't reduce. 4 and 3 also don't reduce. So we're just going to multiply across. 3 times 3 on the top is 9, and 10 times 4 on the bottom is 40. So 9/40 is the probability of both events happening. Okay, now let's look at B. So the probability that both are apple juice. So let's first find the first probability of apple juice. So it says that there are 8 apple juice boxes. So we have 8 out of 40, right? Well, does that reduce? I know that 8 actually goes into both of those numbers. 8 divided by 8 is 1, and 40 divided by 8 is 5. So I get 1/5. Now that juice box is replaced, so we still have 40 juice boxes. We want to know the probability of choosing apple again. So there's 8 apples. So 8/40. We know that reduces to 1/5. So I'm now going to multiply my two probabilities together. 1/5 times 1/5. So 1/5 times 1/5. Does anything reduce? Nope. So I'm just going to multiply across. 1 times 1 is 1, and 5 times 5 is 25. So the probability of both events happening is 1/25. That is the end of our mini lesson on compound probability.